As circuits become more and more complex, they become harder to visualize and perform calculations on. Leon Charles Thevenin. Being an engineer, he didn't like all this hard work, so he decided to make his and everyone else's lives easier. He believed that all these resistors and voltage sources could be simplified and replaced by one load resistor and one voltage source, and lucky for us, he was right. Thevenin's theorem states that any linear circuit containing a combination of several voltage sources and resistors can be replaced by one single voltage source in series with one single resistor. Jumping straight into an example, here we see figure A, a circuit with 3 resistors and a voltage source. Using Thevenin's theorem, we'll transform this to the form seen in figure B. First, we must replace the series voltage source with a parallel current source with the equivalent 16 ohm resistor. As the 20 ohm and 80 ohm resistor are in parallel, they are equal to one 16 ohm resistor. If we now transfer our current source back to a series voltage source, we'll be left with a potential difference of 16 volts and two 16 ohm resistors in series. The 16 volts is now Thevenin voltage. Our equivalent resistance can be determined by doing a resistance sum on our two resistors, producing a final Thevenin resistance of 32 ohms. This final circuit shown is a Thevenin equivalent circuit. As you can see, it is significantly more simple than our original circuit. There is also a second method to find an equivalent circuit that does not involve source transformation, and may be more familiar to some people. The first step is to find the Thevenin resistance. To do this, all power sources are replaced with short circuits and the resulting resistance is determined. To find the Thevenin voltage, a two-terminal network between A and B is considered. The voltage is then determined through voltage divider rule. With the Thevenin resistance and Thevenin voltage, a Thevenin equivalent circuit can be created by placing the two components in series. Some key things to remember when working with a Thevenin equivalent circuit problem is to ensure that you take note of the units of different components, as this can be an easy way to trip up in a calculation, and when finding the equivalent resistance, replace all power sources with a short circuit. And most importantly, please like and subscribe.